Hello all, my name is Sammaish. I am a teacher by profession. We know that the task of a communication engineer is to design a communication system for error-free transmission of data. I also try the same by making most of the solution should be error-free. And I had given all of the solution with the best of my knowledge. And the mode of the coming demonstration is to avoid the ambiguity in the communication solutions. Consider a discrete memory source with the alphabet capital S equal to consisting of S0, S1, S2, S3, S4, so on, and respective probabilities of occurrence capital P is 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, so on. The entropy of the source is. Yeah, this was asked on 30th morning, 1 mark question, and the solution is very simple. The solution which is asked based on the definition of entropy of a source. The definition of entropy of a source H of S is summation of I into P of Si into log of 1 by P of Si base B. Here the professor was asked the entropy in terms of bits. This base B should be 2. Now here it was given the respective probability, so that the probability of S0 is 1 by 2, the probability of S1 is 1 by 4, the probability of S2 is 1 by 8. So the entropy equal to, it is 1 by 2 into log base 2 of 1 by 2, it is 2 plus 1 by 4, the second simple probability S1, probability 1 by 4, log base 2 of 4, and the S2 probability 1 by 8, so that 1 by 8 log base 2 8 plus, and the probability of S3 is 1 by 16, so 1 by 16 log base 2 16, so on, and this is equal to log to base 2 equal to 1, so this is equal to 1 by 2 plus 1 by 4 into log 4 base 2 equal to 2 plus 1 by 8 into log 8 base 2 equal to 3 plus 1 by 16 into log 16 base 2 is 4, so on. And if you take the common 1 by 2, this you can able to write as 1 plus 2 into 1 by 2 plus 3 into 1 by 2 whole square plus 4 into 1 by 2 whole cube. And we know that 1 plus x square plus x cube, so on, equal summation of a geometric series equal to 1 by 1 minus x, and differentiate both sides, you will get 1 plus 2x plus 3x square, this is equal to 1 by 1 minus x, so it is equal to 1 by 1 minus x whole square. So the expression of this, which is in the form of 1 plus 2x plus 3x square, here x equal to 1 by 2, so the entropy of source S equal to 1 by 2 into 1 by 1 minus 1 by 2 whole square, this is equal to 2 bits. So the answer of the question is 2. Data transmission at a rate of 56 kilobits per second using baseband binary pulse amplitude modulation that is designed to have a raised cosine spectrum. The transmission bandwidth in kilohertz required for a roll of data of 0.25 is. Here, the transmission bandwidth formula for a PA modulation for a raised cosine filter is the transmission bandwidth equal to RB by 2 log m base 2 into 1 plus alpha. RB by 2 into log n base 2 into 1 plus alpha, where RB is bit rate, and M is M level, and alpha is roll-off factor, Here it was given it is binary. For the binary case, M equal to 2, so that the transmission bandwidth equal to, the bit rate is given here, it is 56 kilobits per second, so it is 56k by 2 into log 2 base 2 into 1 plus alpha. The rule of factor it is given, it is 0.25. So 1 plus 0.25. So this is equal to, it is 28 into 1.25. It is nothing but you can able to 28 into 1.5. It is 5 by 4. 47. It is 35 kilohertz. 35 kilohertz. So answer is 35. Rodent receiver operates in the frequency range of 58 MHz to 68 MHz. The intermediate frequency F, capital F, and local oscillator frequency F, capital LO are chosen such that FIF less than FLO. It is required that the image frequency fall outside the 58 MHz to 68 MHz band. The minimum required FIF in megahertz is, here the local oscillator frequency is given more than FIF. That is, the FLO equal to Fs plus FIF from the operation of the super heterodyne receiver. The local oscillator frequency equal to Fs plus FIF, and the image frequency Fi equal to signal frequency plus twice the intermediate frequency. Image frequency equal to signal frequency plus twice the intermediate frequency. Now, in the question it was given that the Fs, the signal frequency range is from 58 MHz to 68 MHz. And in the receiver this FIF is fixed, and as the signal frequency is changes, in the super heterodyne this one the FIF is fixed, as Fs is changes, in image frequency changes. So let us assume that, let us take an example. Suppose it has a band of frequencies from 58 to 68 MHz, the channel signal frequencies. And now I am considering that one channel has a carrier frequency equal to 58, another channel has a carrier frequency equal to 60, and another channel has a carrier frequency equal to 62, like that. Then the first channel which has a carrier frequency equal to 58, that intermediate frequency, image frequency Fi1 equal to 58 plus 2 into FIF, and the second channel which has a carrier frequency, I am assuming it is 60, this is Fi2 equal to, this is 60 plus 2 FIF, and Fi3, the third channel I am considering, it is 62 plus 2 FIF, so on. So as the frequency of the channel is changes, the image frequencies changes. Here the professor was given that the image frequencies are fall outside the 58 MHz to 68. That means all these intermediate image frequencies must be more than 68 MHz. That is outside the band of this one. And one more thing, you might get a doubt that why it might be outside the frequency means less than 58. But less than 58 you will get image frequency is a negative value, so that the valid inequality is, it is more than 68 MHz. 68 MHz. So then 58 plus 2 into Fi greater than 600 also. So what is the condition which is satisfy all this one? 58 plus 2 FIF greater than 68 MHz. All condition has to be what? Satisfied. So this implies 2 FIF is greater than 10 MHz and FIF is greater than 5 MHz. So that the minimum intermediate frequency is FIF in megahertz is 5 MHz. So answer is 5. Amplitude of the sinusoidal carrier is modulated by a single sinusoid to obtain the amplitude modulated signal. S of t equal to 5 cos of 600 pi t plus 20 cos of 1800 pi t plus 5 cos of 2000 pi t, so that the value of modulation index is. This is a very fundamental question of a single tone modulation. A sinusoidal carrier is modulated a single sinusoidal. Then the amplitude modulated signal S of t equal to AC cos 2 pi fct plus mu AC by 2 into cos of 2 pi fc plus fm into t plus mu AC by 2 into cos of 2 pi fc minus fm into t. Here AC is the carrier amplitude and FC is the carrier signal, central carrier signal frequency, and mu is the modulation index, and FM is the single sinusoidal frequency. And compare S of t with the above equation. Here S of t, okay, now I am representing in some order. See here, mu AC by 2, mu AC by 2, this is nothing but 5 and 5 here it is given, and the AC is given here 20. So now I am making shuffling this order of the given signal is 5 into cos of Fc plus Fm, which is more than 1800, it is 5 into 2000 pi t plus mu AC by t into cos of, it is 5 into cos of 1600 pi t. Now compare this. AC equal to standard AM signal, AC equal to 20 and mu AC by 2 equal to 5. This implies mu equal to 10 by AC, this is equal to 10 by 20, so this is equal to 0.5. So answer is 0.5. S of t is transmitted over an AWGN channel, additive white Gaussian noise channel. The received signal is R of t equal to S of t plus N of t, where N of t is additive white Gaussian noise with PSD, power spectral density capital N0 by 2. The received signal is passed through a filter with impulse response H of t. Let ES and EH denote the energy of the pulse S of t and the filter impulse response small h of t respectively. When the signal to noise ratio is maximized at the output of the filter, which of the following holds? Here the question is given: an analog pulse which is transmitted through an AWGN channel, additive white Gaussian noise. Here then the noise is added in the channel and the received signal R of t equal to, given, see here, R of t equal to S of t plus N of t, and where N of t is additive white Gaussian noise with PFT. White Gaussian means this noise is a Gaussian random process, and whose power spectral density is a white. Power spectral density of this noise is white. White means pure transparent. That means all the frequency component has same PSD. That is equal to N0 by t. It is given, and which is, and the received signal, that R of t, the received signal is R of t, is passed through a filter. Whose impulse response H of t. Let, here it is given ES. ES is the energy of the signal and EH is the denote the energy of the EH is the energy of the H of t. Now the professor asked that when the SNR is maximized at the output of the filter, which of the following will holds? And the filter which is maximize the output signal to noise ratio, that filter is matched filter. That filter is matched filter. And for the matched filter impulse response derivation, we get the impulse response is which is matched to the input signal S of t, that is S conjugation of minus of t minus capital T, where this t is the symbol duration. So that if you are find the energy of the signal EH, this is nothing but minus infinite to infinite mod H of t whole square dt. This is equal to minus infinite to infinite capital S conjugation of minus of t minus capital T whole square dt. So this is equal to energy of the symbol. So the EH equal to ES, and the signal to noise ratio of the matched filter, is less than or equal to the energy of the signal by the power spectral density of the white noise. Energy of the signal S of t ES by N0 by 2. So the signal to noise ratio is less than or equal to 2 ES by 2s by n naught, so that the signal to noise ratio maximum value equal to 2es by n naught, so that option A is the right answer. So that option A is the right answer.
ఇది చూడండి సార్
వీడియోనా
ఫోటో.
System uses a repetition code for channel encoding and decoding. And during the transmission, each bit is repeated 3 times. That is, 0 is transmitted as 3 zeros and 1 is transmitted as 3 ones. And it assumed that the source puts out the symbols independent and with equal probability, and the decoder operates as follows. In a block of 3 received bits, if the number of zeros exceeds the number of ones, the decoder decides in favor of a 0, and if the number of ones exceeds the number of zeros, the decoder decides in favor of a 1. Assuming a binary symmetric channel with crossover probability p equals 0.1, the average probability of error is here. The professor is given. In the repetition code, actually we are repeatedly sending the same bits to transmit a single bit. 0 is transmitted with 0, 0, 0, and 1 should be transmitted with 3 ones. And this is passing through a channel, and the receiver is decodes. The decoder operation is based on the majority bits. Here, the zeros exceed the number of ones, the decoder decides in favor of 0. That means if and again the number of ones exceeds the number of 0, the decoder decides in favor of a 1. That means whichever is more. Suppose in 3 zeros, if the number of zeros in the received code word is more number of bits zeros, then it is detected as 0, otherwise it is as 1. Now error means this 0 has to be detected as 1 should be error. That means if I am transmitting 0, 1 detected as 1 should be error, and if we are transmitting 1 and this should be as 0, that should be the error case. And when error should be what happen in all out of these 3 zeros, 2 bit positions must have 1. That is, either these 2 bits are 0 0 converted into 1 1 1 1 0, so majorities are 1, so that the decoder is decides 1. And if 0 1 1, again it decodes 1, and if it is 1 0 1 also, again it decodes 1. If all 3 zeros are converted into 1, so 1 1 1 also decoded as 1. So similarly, if we are transmitting 1, these 3 ones, out of these 3 ones, at least 2 ones has to be what converted into 0. Then the majority bits in the received bits should be 0, so that the receiver is decoded as 0. Suppose so now I am considering a random variable capital X. So the capital X is the number of transition bits. Transition means 0 is converted into 1 and 1 is converted into 0. That is called transition. Now, if the number of transition bits more than or equal should be the error. That means if it is out of these 3 zeros, if 2 zeros are converted into 1 1, then it should be what? Okay, minimum 2 bits position has to be bits has to be changed, so that the error should be occurred when the number of transition bits more than or equal to 2. So this is equal to probability of x equal to 2 plus probability of x equal to 3. And here, what are the number of bits? Those are transmitting 3 bits. For every bit, it's transmitting 3. So that it is 3C2, binomial distribution. 3C2 into what the transition probability? If I assume that the transition probability P, there is P to the power of 2 into 1 minus P to the power of 3 minus 2. And of course, you know that the binomial distribution function, probability of x equal to r equal to NCR, P to the power of r, and 1 minus P to the power of n minus r. So next P of x equal to 3. So 3C3 and P cube into 1 minus p whole power 3 minus 3, so that the probability of error equal to the probability of error equal to 3c2 is nothing but 3, so 3p square into 1 minus p plus 3c3 equal to 1 and p cube into 1 minus p to the power of 0 equal to 3. So this is equal to, it is 3p square minus 3p square into p, 3p whole cube plus, so minus 2p whole cube. If you take the common p square, then you get 3 minus 2p. Here the transition probability nothing but crossover probability. It is one name, another name of the transition is crossover. So the crossover probability p equal to 0.1. So substitution of what p value here, 0.1 whole square into 3 minus 2 into 0.1. This is equal to 0.01 into 3 minus 2.01. It is 3 minus 0.2. 2 into 0.2 means 0.2. 3 minus 0.2 is nothing but it is 2.8, and 2.8 multiplied with 0. This is 0.028. So the probability of error equal to 0.028. So answer is the probability average bit error equal to 0.028. And average this year ISC Bangalore is given 10 questions from communication system for each and every paper, and most of the questions are simple and formula substitution, and some of the questions are concept oriented, but always preparation is formula orientation is not at all failed. You have to always prepare the subjects with some conceptual intuition and prepare more number of concepts rather than solving more number of questions on the same concept. And for the, especially for the communications, you read most of the concept from the probability and random process. Why? Because that subject should be the basis for the communication systems. Once you have get some idea and familiarity in the random process, the solving of the question from the communication systems is very simple. It is generally in most of the questions you can able to solve 3-4 steps only. It's not a big task, but it requires some mathematical background of the probability and random process. And apart from that, I would like to tell you, you have to practice unsolved question of some standard books. It might be the communication systems by Prokis or Simon Akin or B.P. Lathi. So which book you are following in your graduation, but you have to solve all the unsolved questions that was given an exercise. Okay. Okay. While learning the concept, you must be clarity about the concept. Rather than getting more information regarding the concept, you must be clear cut about the concept. Each and every term you must be clear. And my dear friends, and you must be practice. That means revise. It is most important thing. It's not only the communication system subjects. For every subject, revise is most important thing. When you are properly planned for the revision, then you will get a very good marks in the communication systems. And all the best and best of luck. And if you have any doubts regarding these solutions or any communication systems doubts, you might mail me to my mail address, that is samgupta005@gmail.com. SAMGUPTHA005@gmail.com.